Hey guys, welcome back. Today we're going to talk about another concept from chapter 4 called Electron Arrangements. Again, this is meant to be a review, so if you have not gone over the information from chapter 4, please look at that first and then come back and listen to this presentation. Electron arrangements. Electrons are super important in the world of chemistry. Electrons dictate everything that happens. Electrons dictate, do atoms come together and form a bond? What kind of bond do they form? How do those bonds interact with other bonds that are floating around them? So electrons are super important, and they're something we're going to refer back to from now until the end of the semester. Your textbook talks about electron arrangements. Electron arrangements are more of a simplistic view of where electrons are. Your textbook talks about what we call the shell model. So the shell model puts electrons, of course, around the nucleus in these kind of two-dimensional rings, and they're called energy levels, which we'll see on the next slide. Reality is a little bit messier and a whole lot more complex. Reality is called the quantum mechanics model. If you were to take my Chem 151 course, we spend 2 chapters just talking about this three-dimensional space around the nucleus and where we would find the electrons and how they file in. So really complex topic. We are going to take the simplistic approach. It's not wrong. It's just much more simplified. Electrons file into their homes. So they file into these rings or these levels in a very particular manner. The principal quantum number. So the principal quantum number, and the way that our textbook refers to it, is energy level, is where an electron resides. So those rings, if you will. Electrons will always go into the lowest energy level first and then work their way to higher energy levels. So the analogy that I always put out there, I have 2 sons. They're 5 and 2.5. So let's say I'm sitting on the floor and I'm reading books with my kids, and the books are spread out all over the floor around us. Now it's time to pick up those books. So I pick up the first book. Am I going to stand all the way up and put that book on the highest bookshelf? No, I'm not, because I'm a lazy chemist. Where am I going to put that book? I'm going to pick up that book. I'm going to put it on the bottom bookshelf right next to me. So I'm going to put it on the first bookshelf. And I'm going to keep putting books there until it's full. Well, the first bookshelf only holds 2 books. I'm going to pick up the next book once that shelf is full. I'm going to pick up the next book. I'm going to say, that shelf is full. I guess I got to reach up to the shelf next to my head. And I put that book on the second bookshelf. And I'll keep putting books there until that shelf is full. That shelf holds 8. Then, once that shelf is full, I'll pick up the next book and I'll say, the bottom 2 shelves are full. I guess I'm going to have to get on my knees and put it in the third bookshelf. And I'll continue to fill bookshelves that way from the bottom up until all the books have a home, until all the books are gone. Electrons do the exact same thing. They're going to fill the bottom energy or the lowest energy level first. So this N equals 1 bookshelf. Then they'll go to the second energy level and the third and the fourth all the way to the top. So electrons really behave very much like we do. Those bookshelves are called energy levels. Each energy level holds a maximum number of books or a maximum number of electrons. So the equation to determine the energy level is 2n squared. What is n in this case? It's whatever bookshelf you're on. So if it's the first bookshelf, n equals 1. If it's the second bookshelf, n equals 2, so on and so forth. So if we look down here at the first 3 shelves, on our first bookshelf, n equals 1. So if we plug 1 into this equation, we would have 1 squared, which is just 1. And then we multiply that by 2. So the first bookshelf holds 2 books. The second bookshelf, so n equals 2. So we would take 2 squared. So 2 squared is 4. And then we would multiply 4 by the number 2, which is 8. Second bookshelf holds 8 books, so on and so forth. Now we know how electrons file into place into their rings or bookshelves. Before we can start working examples, now we need to determine, well, how many electrons do each of the elements have? For right now, we're going to assume that these are neutral elements. So the number of protons is equal to the number of electrons. Protons, positively charged particle. Electron, negatively charged particle. So if I have 1 proton, 1 electron, that's electrically neutral. They would balance each other out. So for example, here's helium. Helium has 2 protons. And for right now, we're going to assume it has 2 electrons. Over here on the left, sodium has 11 protons. And we're going to assume that it has 11 electrons. So number of protons and number of electrons are the same. So let's start working some examples. How would we write an electron arrangement? What we're going to do now is the electron arrangement for, let's start simple, the electron arrangement for helium. Clicking back to our periodic table, I see that helium has 2 protons or 2 electrons. So now we just write where those electrons are. How many books does the first bookshelf hold? It holds 2. So helium has 2 electrons, and both of those would go in the first energy level. Easy peasy. Now let's look at boron. So let's go over here to boron. Boron has how many electrons? It has 5. So boron, I'm just going to make a note over here, has 5 electrons. So now I need to find out where those electrons are. What energy levels are they in? How many electrons does the first energy level or first bookshelf hold? It holds 2. That bookshelf is full. Now we need to go to the next bookshelf. How many electrons go in the second energy level or on the second bookshelf? Well, it can hold up to 8, but do we have 8 electrons to put there? No, we just have 3 more electrons. 2 went on the first shelf, so the last 3 are going to go on the second shelf. So that's how we write electron arrangements. we basically tell the viewer how many electrons are in each energy level or how many books are on each bookshelf. And we separate each bookshelf with a comma. That's it. I hope you guys found this helpful. We are coming to the end of this first exam information. So please make sure that you guys are starting to pull this information together and starting to prepare for that first exam because it's going to come pretty soon. Happy studying!